Hello, we're group 4. We did the case study of Ed Taylor, which is a case study on examining nonlinear growth patterns. Our group consists of Melissa Williams, William Clark, Robert Schmitz, Wanda Bowers, Sarah Jean Baptiste, Sean Zhao, Kayla Porter, and Brianna Murray. And we just want to say thank you to the previous groups that went before us, and we hope you enjoy the presentation.
I'm Sin and I'm going to start our group presentation. So today we're going to present the Ed Taylor case. At the beginning of this case, we have an opening activity which gives us the question that Mr. Taylor will introduce to his class in this case. This activity helps us to understand the mathematical ideas in the case and encourage us to start thinking through the model that Mr. Taylor will discuss in his case. So the question is, write a description that could be used to define any steps in the square and S patterns. You may use drawings, words, and numbers in your explanation, and your answer should be clear enough so that any other person could read it and understand your thinking. So, as a teacher, before we teach students how to solve a problem, we should prepare multiple ways to explanation and justification and consider the possible question that student might ask when they demonstrate the problem and prepare multiple ways to answer. So in this case, we will see Mr. Taylor ask his students to solve the problem, and there are many differences among students' understanding and demonstrations, and how Mr. Taylor guides his student to understand this mathematical idea through the question.
In the introduction for this case, we learn that Ed Taylor has spent his first 2 years at Richland Middle School teaching reading, language arts, and social studies. When a math position opened up, he decided to switch because of the passion and care that the teachers in that department show towards their students as well as towards what they are teaching. Despite not having a background in mathematics, Ed is pleased with the end of his first year as a math teacher. He's worked throughout the year with Ron Trenton, who also teaches 7th grade math, to plan engaging lessons and to reflect on their completed lessons. Ed stated in regards to their planning that nearly everything they talked about has to do with creating models so that the students will get a better understanding of the topics that they're teaching. Ed also enrolled in 3 courses, along with some of his other colleagues, that focus on learning in math, specifically one that promotes a visual approach to learning algebra, as that's one of the more important subjects that they teach.
Mr. Taylor's students learned about numeric and geometric patterns in 6th grade. Over the year, they explored various topics related to pattern recognition, such as odd and even numbers, perimeter, and ratios. The focus was on identifying patterns, describing what larger arrangements within a pattern might look like, such as the 10th or 20th step, and figuring out a method to calculate the total number of objects in a pattern for a given step. In the 7th grade, the curriculum builds on their previous experience with patterns, and the students move from verbal descriptions to using symbols to describe patterns. Mr. Taylor's class is now on the second day of a unit on patterns, formulas, and graphing. They worked on the square pattern task the previous day and are now working on the S pattern task. Mr. Taylor had his students work on the S pattern task independently for 5 minutes, in small groups for 15 minutes, and finally as a whole class discussion. This allowed them to explore and come up with ideas about the pattern. During the class discussion, Mr. Taylor asked for a volunteer to draw the next 2 steps and strategically chooses Michael, a student who rarely volunteers. Michael demonstrated how the pattern progresses by adding a column and then a row while keeping the tiles sticking out on the top and bottom. Mr. Taylor further asked if he could predict future steps based on his observed pattern. Michael replied that if you knew what the last step was, you could always get the next step by adding a column and then a row.
Observations about the S pattern. We start with the student observation. Mr. Taylor asked the students to share their observation about the pattern arrangements. Shirley started the discussion off, stating that the top and bottom rows extend out by one extra tile. Angela stated that whatever the step number is, there is one less column. Charlotte observed that the top and bottom rows both equal the step number. Maria's group observed that the number of rows is one more than the step number. Dwayne commented that if you square the step number and add 1, you get the total number of tiles. Mr. Taylor asked the class to check to see if Dwayne's comments was true with steps 6 and 7. Joey explained that it works as he had squared step 6 and added 1 for a total of 37. Marsha commented that on step 7, there are 50 tiles, so 7 times 7 plus 1 is 50. Renee also shared that each arrangement was a square in the middle and 2 skinny rectangles on the top and bottom. Kevin added that he thought the arrangement was a rectangle with an extra square on the top right and bottom left corners. Now, Mr. Taylor asked his students to look at the comments and see if they notice any similarities or differences. Jamie observed that Dwayne's comment talks about the number of tiles, but is different due to not knowing the shape of the step and how it matters to build the next one. Denise stated that she agreed with Jamie, but also added that none of the observations gave enough information to actually build one.
For this section, I wanted to stop and focus on how Mr. Taylor is utilizing SMPs and MTRs in his classroom. Paragraph 19 shows the student Lamont modeling and using a combination of previous observations that Mr. Taylor put together from the class discussion. He's making connections in determining those multiple steps in the pattern. Mr. Taylor is allowing student discourse and for them to have those discussions and to make those connections from each other's observations. You see where he's praising his students' efforts and providing appropriate tools for learning. So I feel like Ed Taylor's classroom exemplifies true or authentic use of SMPs and MTRs. We see that Mr. Taylor is allowing his students to, to challenge themselves, allowing them to engage in true mathematical thinking and reasoning. I think his classroom exemplifies authentic learning. Allowing them to think and reason are strategies deemed to promote deeper learning and understanding. We can say his students are engaging in effortful learning and collectively and individually demonstrating understanding as they're looking at the problems in so many various ways. The students are seeing those patterns, they're seeing those structures, and they're reflecting on each other's work. Mr. Taylor is encouraging those mathematical thinking as he's asking those probing questions as students are looking closely at what other students are discussing and coming up with. And he's allowing those students to critique each other's work and allowing his students to reason and to make connections.
So after the students were finished making their observations, there was one last step to complete the S pattern task. Mr. Taylor wanted them to make a formula. And even though it wasn't explicitly stated in the case study, when you were reading the case study, you could tell that he had a few goals in mind. One of those goals was to support their work through the previous observations that they'd made. When they were making their formulas, he wanted them to simplify those patterns to the easiest way to calculate. Once they did that, he wanted them to be able to calculate any step number accurately. And in the case study, we noticed there's a few issues that students run into there, and he's had to help them out. And then probably the most important part was when they came up with their formula, he wanted them to explain how they made it. And when they did this in the case study, there were a lot of light bulbs going off. There was a lot of connections being made between the similarities. So just to recap, there were 7 observations made about the S pattern, and just really quick what they were. The top and the bottom rows had an extra tile. Whatever the step number is, there's one less column. The top row is always the step number. The number of rows is always one more than the step number. If you square the step number and add 1, you get the total number of tiles in the sequence. Each step has a square in the middle and 2 skinny rectangles on the top. And the arrangement is a rectangle with an extra square on the top right and the bottom left corner. So obviously this isn't all of the observations the students could make, but with this, students were able to go ahead and start writing formulas. And the first student to raise her hand to offer a formula was Ning. She said that the number of tiles for any sequence can be calculated by multiplying the columns and rows together and adding 2. And so if you look at the figure to the left, you can see there are 4 columns and 6 rows. And if you add the 2 extra tiles on the outside of it, you would get the number. And so she had to make a formula for that. And she determined that the columns could be calculated by taking the step number, and in this case 5, and subtracting 1 from it, and you'd have n-1. And then you could calculate the rows by taking the step number and adding 1. So since this is step 5, it would be 5 plus 1, and that's 6. And then you add the 2 original tiles that are to the side that weren't calculated, making the multiplying the rows and the columns, and you get our formula. The tiles are n-1 times n plus 1 plus 2. So after Ning stated her formula, David raised his hand next, and he said that he preferred to be able to calculate the S pattern by thinking of it as a square and calculating the square in the middle, and then 2 skinny rectangles, one on the top and one on the bottom. The square, he said, you could calculate by taking the previous number, which he called Pn, and multiplying it by the previous number again. And Mr. Taylor had to help him write this algebraically correct, so the previous number is n-1. And so he ended up writing n-1 times n-1. The skinny rectangles on the top and the bottom were equal to the step number, and so in this case, since the step number is 5, it would be 5. He would add 5, and he would do it twice. He'd multiply it by 2. The final formula is n-1 times n-1 plus n times 2. After David, Charles was the next to come up with a formula. He stated that by making a square, just like David did, you could figure out how many tiles. He did it a very different way, though. He took one of the rows, the bottom row, and he moved it to the side. And if you do that, You transplant the lower row into the column. You end up making a square with sides that are equal to the step number. So in this case, if it's step 5, each side is 5. And if you have one tile left over, which would give us the formula n squared plus 1. After Charles, Beverly raised her hand, and she gave a formula that was very similar to Charles. And when Mr. Taylor was asking her about this formula, it didn't make a lot of sense intuitively. She said, well, if you multiply n times n and add 1, you would get the number of tiles. And although that was correct, she had to actually go up and explain what she meant. And then it became clear that unlike David and Charles, who relied on the use of those square patterns, she actually was coming up with n times n with grouping. She would take the step number, so in this case step 5, and she would use that as a guide, and she would find 5 groups of equal numbers, 5 and 5, and she would circle them. And so since it's the same number in each group and the same number of groups, algebraically that's n times n, there'd be one tile left over, and so her formula was n times n plus 1. All right, and so with that in mind, Tanya was the last student to share before they started running out of time, and she made the connection that Beverly and Charles' formulas are actually exactly the same, but although Charles moved the bottom row to create the square, the formula didn't rely on it. It didn't have to go that way. The groups could be arranged in any order. So both arrangements had the same number and the same groups, which is equal to the step number. So the actual way that it looked was not part of the formula. The formula could tell us regardless of how it looked. All right, so there was only a few minutes left in class, so Mr. Taylor wanted the students to really quickly observe a few things, and so he wrote all the formulas off to the side, and then he added one other, formula 5, from that was discovered in another class. It was n plus 1 times n minus 1 minus 2n. And students were asked to write in their journals and explain how they knew that all the formulas to the left were equivalent to one another. And they were getting ready to, after they did that, the very next day, they were going to start graphing it.
Hello, my name is Kayla Porter, and I'll be talking to you about analyzing the case and extending your analysis. After reading the case of Ed Taylor, you should begin to think about student learning and practices you can incorporate to support your students. After learning about the case, here are a few things that you can consider. Identifying the key pedagogical moves that Ed Taylor made to support his students. You could start by analyzing each student in the case and determine what he or she learned. For each student, Mr. Taylor used different methods to support their learning. Try to identify what he did and why he did it. The book recommends making a 3-column chart showing each key pedagogical move, the rationale for the move, and implications of the move. If you're reading with a colleague, compare and contrast ideas that you have about the case. After discussing, make a master chart on points you agree or disagree with. Any disagreements can be topics for discussion or debate. The chapter also lists some questions you should consider about teacher decision-making and student thinking. Mr. Taylor and his colleagues decided to adapt a lesson by adding additional parts to the original task. What did they make this change? How did the changes impact the difficulty of the task? How did the changes affect student learning? Earlier in the case, we learned about Michael and his explanation for the S pattern and how you needed the previous step to find out what the next step is. What does Michael's explanation tell you about his reasoning on the pattern? How does this differ from his classmates Ning, David, Charles, or Beverly? Can you make a generalization for the pattern off of Michael's thinking? Mr. Taylor added the 5th formula to the list of formulas and tells his class that they are algebraically equivalent. Why do you think he added the last formula? And how would you expect the students to justify why the 5 formulas are algebraically equivalent? And finally, Mr. Taylor stated in the case that
I don't like to just correct mistakes. I don't think students learn from this. I try to guide students to the right answer by asking appropriate questions. Do you agree or disagree with this statement? Are there any instances that are consistent or inconsistent with Mr. Taylor's statement?
This section offers multiple ways to connect the specific ideas that the authors of the case of Ed Taylor developed and reported on in Chapter 3. This section makes connections that teachers of mathematics can make in their own classrooms. Extending your analysis of the case of Ed Taylor, the authors provide all of us with opportunities for focused reflection on understandings and developments that might be important to you and your own mathematics instruction and discovery. The authors of the case of Ed Taylor further share that in the Analyzing the Case section, there were ways in which Ed Taylor supported students' learning. Choose one of the key pedagogical moves made by Ed Taylor during the lesson that currently are not part of your pedagogical repertoire. For example, you may be curious about how Mr. Taylor pressed the students for justifications and explanations. You might then plan and teach a lesson in which you make a concerted effort to press students for justifications and explanations. If possible, videotape you teaching a lesson, or have a colleague observe and take notes, then reflect alone or with a colleague on the impact of the pedagogical move on students' learning or engagement. If no impact is noted, consider ways in which the pedagogy can be refined. The authors of the case of Ed Taylor also state that as teachers, we could give our students the S-pattern task or a similar task from our curriculum in order to discover the strategies that our students use to solve problems of this type. Review students' responses and identify the different strategies and representations used by the students. Then develop a set of questions you could use to help students make connections between different solution paths. Exploring curricular materials. You may want to explore mathematics curriculum for ideas related to nonlinear growth patterns by considering the following questions. Are nonlinear patterns found in your curriculum? If so, what opportunities do students have to compare linear and nonlinear patterns? How would making such comparisons help develop students' understanding of functions and functional relationships? If nonlinear patterns are not found in your curriculum, how and where could they be included to give students opportunities to expand their view of functions? You may want to solve additional tasks to continue to explore the mathematical ideas made salient in this case. Please look at the resources listed at the end of the case of Ed Taylor. I trust that you will find these resources are beneficial and enlightening. In our question sections, there are 5 questions we've asked the students to answer. Number 1, are nonlinear patterns found in your curriculum? If so, what opportunities do students have to compare linear and nonlinear functions? How would making such comparisons help develop students' understanding of functions and functional relationships? If nonlinear patterns are not found in your curriculum, how and where could they be included to give students opportunities to expand their view of functions? Number 2, giving students multiple ways to find a solution can create confusion for students. Do you agree? Why or why not? Why would this be a beneficial strategy for student learning? In this case, we do not see any form of explicit instruction from Mr. Taylor. Do you think Mr. Taylor should spend all his class time focused on discussion? Why or why not? Do you think the strategy he used in this case is more effective than teaching students explicitly how to generate the formula? Number 3, Mr. Taylor's comments. I don't like to just correct mistakes. I don't think students learn from this. I try to guide students to the right answer by asking appropriate questions. Paragraph 23. Discuss whether you agree with Mr. Taylor and why. Cite examples from the case that are consistent or inconsistent with this stated belief in how Mr. Taylor's actions may have influenced student learning in positive or negative ways. Number 4, the authors in the case of Ed Taylor specified key pedagogical moves made by Ed Taylor during the lesson. Please pick out one of the key pedagogical moves made by Ed Taylor that are not currently part of your pedagogical repertoire. For example, You may be curious about how Mr. Taylor pressed the students for justifications and explanations. Please explain how you would plan and implement these key pedagogical moves or a particular key pedagogical move in your class. And lastly, number 5, Mr. Taylor ends the class by asking students to discuss the 5 different formulas that were on the board and to explain why they were equivalent. Paragraph 31. Why do you think Mr. Taylor added the 5th formula? How would you suggest Mr. Taylor use his students' journal reflections as the basis for a discussion the following day? How would this fit with what he had planned for the class? Graphing both the S and square patterns and making observations about them.